Hello, and welcome back to Sleepy Tales by Slate. Tonight, we're going to talk about gravity, one of the most fundamental aspects of reality. The thing that keeps your feet firmly on the ground, the force that guides Earth around the sun, and the quiet rhythm that governs the motion of galaxies billions of light years away. But here is the part that fills us with wonder. Gravity is not truly a force. It is something softer, subtler, and more beautiful than anything we once imagined. Every discovery tonight, whether small or vast, will feel like a silent piece of the universe's story gently sliding into place. A story so wide, so breathtaking, it stretches beyond the boundaries of human thought. If you enjoy these slow and quiet journeys, you can like, subscribe, or share your reflections. Perhaps your whisper will guide another wandering soul to this peaceful corner. Now, let us begin our journey into what gravity truly is. Let us start with what Newton said when he watched an apple fall from a tree. In that moment, a question rose in his mind. Why does it fall straight down? Why not to the left or to the right? And why does the moon not fall in the same way? Imagine that you are sitting beside him now, under the softly rustling leaves in a golden afternoon. Newton watches the apple fall. And you, here in the gentle imagination of tonight, are watching him. And you can sense, like the faintest brush of wind, that this moment would forever change the way humanity thinks about the world. In the cosmic picture Newton painted, everything felt simple and wonderfully logical. He imagined Earth as a giant holding everything with invisible strings. Every object with mass could pull on every other object, and since Earth is the heaviest object near us, everything falls toward it. To Newton, gravity was a pull, and the strange thing wasn't that objects fall, but that the moon does not. You can picture Newton lifting his head toward the night sky, a sky much like the one you see when you can't sleep, when your heart feels full or when your mind longs for rest. He sees the moon drift gently across the darkness and wonders, if the same pull acts on both the apple and the moon, then why does the moon never fall to Earth? Then, like a silver thread sewing intuition to mathematics, he realized, the moon is falling, but it falls endlessly along Earth's curve. And this is why it never touches the ground. From here, Newton wrote the law of universal gravitation, a rule that transformed everything. Any two objects with mass attract each other. The heavier they are, the stronger the attraction. The closer they are, the greater the pull. And with that, a new chapter of human understanding opened. Tonight, as your gaze softens and your breath slows, try imagining this. There is a gravitational pull between you and the phone sitting on your table, between you and the wall, between you and the small night lamp glowing beside your bed. They pull you, you pull them. Though the force is so faint you will never notice it, but for the enormous bodies of the cosmos, planets, stars, galaxies, this pull becomes powerful enough to sculpt the universe itself. In Newton's picture, everything finally had order. Gravity explained why planets move, why the oceans form tides, why comets bend into graceful arcs instead of flying straight. The world was like a giant machine, woven together by invisible strings, so tidy, so elegant, so easy to understand. But just like a flat map can never fully describe Earth's roundness, Newton's picture was only an approximation. It was convenient, incredibly accurate for most things, enough to send humans to the moon, guide satellites, and predict comets, but still missing a deeper layer. A layer Newton, brilliant as he was, could not reach in his century. It was like hearing a beautiful piece of music through a phone speaker. You know it's lovely, but only when you sit before the real orchestra do you discover all the layers that were hidden before. And in that quiet space, between what was known and what had yet to be understood, a new doorway of the universe opened. A doorway that, many years later, a man with dreamy eyes and unruly hair named Albert Einstein would step through, showing the world that all those invisible strings were only illusions. But now another question waits. If gravity is strong enough to guide Earth, the Sun, and distant planets, then why don't you feel it when you stand beside someone else? Why don't you get pulled toward them, even a little? And from this silent question, we enter a new chapter, where gravity reveals the surprising softness at its core. Let me invite you to relax just a little more. Notice the tiny space between you and the nearest object in your room. Maybe the table, the pillow, or the cat curled at your feet. Now imagine that between you and that object, there is a real gravitational pull. Yes, absolutely real. But so faint that it loses to the soft breeze stirred by a ceiling fan across the room. Gravity, the ruler of cosmic motion, turns out to be a giant wearing fluffy slippers. Mighty beyond measure, yet, when it comes close, its footsteps are so soft they hardly leave a trace. And as your mind grows quieter, something beautifully strange emerges. Gravity is the weakest of the four fundamental forces. So weak that even a tiny refrigerator magnet can overpower the entire gravitational pull of Earth trying to hold down a paperclip. Think of that. A child could lift a tiny magnet, yet that magnet can defeat the pull of a planet weighing trillions upon trillions of tons. Gravity is incredibly weak, but that weakness is exactly what allows the universe to be so beautiful. If electromagnetism is like a child with a microphone, loud, energetic, impossible to ignore, then gravity is the silent giant, moving slowly, rarely speaking. It only reveals its true power when you look far enough and large enough, where planets orbit their stars, where galaxies swirl, where light bends, because space dips downward like a deep, quiet pool. In everyday life, you never feel two people attracting each other, because gravity is too shy, too gentle. It becomes meaningful only when the objects involved are enormous, like the great spheres of the cosmos. But this softness does not make gravity insignificant. Instead, it makes it delicate. A quiet heartbeat of the universe, slow but steady enough to hold galaxies together for billions of years. And here is a simple but enchanting thought. If gravity were even slightly weaker, planets would lose their atmospheres, stars would fail to stabilize, and life could not exist. If gravity were stronger, stars would burn too fast and die before creating the elements needed for life. The universe chose a gentle gravity, so that life could bloom. From this delicacy, humans achieved something extraordinary. They discovered unseen planets simply by noticing tiny trembles in the orbits of known celestial bodies. Neptune, one of the solar system's most beautiful worlds, was found not by looking, but by gravity's mathematics. A planet invisible to the eye, revealed only because Uranus wobbled slightly as if tugged by a hidden hand. Everything becomes more magical when you realize gravity, though too weak to feel daily, becomes a language when paired with patience and mathematics. An ancient, secret language that, when listened to closely, tells stories from billions of kilometers away. Gravity is the giant in fluffy slippers, silent, slow, humble, but each of its steps shapes the universe. And so we ask, how can something so soft and weak spin planets, bend light, and gather galaxies into arms stretching hundreds of thousands of light years wide? Its weakness is merely the surface of a deeper truth, a truth Newton, brilliant as he was, could not yet touch. And just like someone walking through a quiet forest and noticing a glowing doorway ahead, humanity once stood at such a threshold. A moment when all old ideas of gravity had to be gently set aside to enter a new way of understanding. Imagine standing before that door now, your hand on the cool handle, drawing in a slow breath. Behind it stands Einstein. Not the stern textbook figure, but a quiet man with soft, wandering eyes, following invisible threads stretching across the universe. He did not believe in Newton's pulling force, not because Newton was wrong, but because something subtler was happening beneath every motion. Einstein believed that space and time, two things we once thought separate, are threads woven into a single fabric. A soft, vast, elastic sheet laid beneath every star, every planet, every grain of dust, and every breath you take. In his view, space is not just where things exist. Time is not just when things happen. They are two sides of the same cloth. Spacetime, and the wonder begins here. Close your eyes a little more. Imagine standing on that soft fabric, in gentle golden lamplight. Place a small pebble on it. It creates a tiny dip. Place something heavier, and the dip deepens. A very light object, a book on your desk, creates a curve too small to see, but replace that book with a planet or a star, and the curve becomes enormous, guiding the motion of everything around it. Here lies humanity's turning point. Gravity pulls nothing at all. There are no strings, no invisible forces connecting Earth to the sun or your body to the ground. Gravity is simply the result of space-time bending under mass and energy. Drop a marble onto a curved cloth and it will not move in a straight line. It will circle the dip, not because something pulls it, but because the straightest, most natural path has become a curve. This is how the universe moves. Earth is not pulled by the sun. It is simply following a straight path through curved space. And you, as you walk, are moving along tiny curves in that gentle fabric under your feet. Einstein discovered this during long afternoons alone, imagining himself falling from a rooftop. In that moment of free fall, he realized, gravity disappears. Only smooth motion through a curved space remains. And from that single insight, one of the most beautiful ideas in science was born. An idea that makes the universe feel soft and flexible, like a vast ribbon. If Newton helped us understand that everything attracts everything, Einstein helped us understand why. If Newton drew the map, Einstein revealed the landscape. If Newton laid the foundation, Einstein opened the sky. Notice, in every tiny movement, a falling leaf, a raindrop resting on the window, the pen slipping from your hand as sleep begins to claim you. Nothing is being pulled. Everything is simply following the shape of the space-time around it. And when you imagine that fabric large enough, you begin to step into a realm of understanding that makes the heart pause for a quiet beat. Stars bend the universe so deeply that even light must change its path. Galaxies swirl and turn because the surface of the universe beneath them is shaped like a colossal bowl. And in the farthest reaches, there are places where the curvature becomes so steep that nothing can escape again. Places we call black holes. But black holes are only one part of the story. The most important thing is that from the moment Einstein wrote down his first equations, gravity was no longer a pulling force. It became a kind of poetry, a geometric language of the universe. Right now, another question naturally rises. If everything is truly a fabric, then what paths are things following? We already know gravity does not pull anyone. We already know everything is simply moving through curved space. So what do those paths look like? And why does every object choose them as if they were destiny? Let us slow down, very slowly, the way night wraps its arms gently around you. Imagine a small room, lit with soft golden light spreading across the floor. At the center lies a piece of fabric, smooth and calm like the surface of a lake before anyone touches it. We place a heavy sphere in the center. The fabric dips, forming a small valley. Now drop a marble near the edge. You'll see it does not travel in a straight line as it would on flat paper. Instead, it drifts inward, circling, gliding as softly as a dancer, searching for the direction of the wind. Nothing is pulling it. No mysterious force is holding it back. It is simply following the true straight line of curved space. A straight line in a world where straight no longer exists, yet the path remains the most natural one, chosen without any resistance. No. In the three-dimensional world we live in, geodesics are exactly how Earth, the Moon, the planets, clouds of dust, and even individual photons walk their paths. Einstein did not just weave the fabric of space-time. He showed us the invisible pathways upon it, the routes every object wants to follow. The same way water always seeks the lowest place, or sleep quietly finds tired eyes. Planetary orbits turn out to be the most beautiful, smooth, gentle geodesics on the surface of the universe. Earth is not being dragged in circles by the sun. It is simply moving straight, but straight in a space that has been bent, like a marble rolling on a curved cloth, like a soft brushstroke following the curve of a page, like a small boat drifting with the current, unaware that the water itself is curved by the wind. And in this bending, time joins the dance. Every step you take, every soft breath, every moment you fall into sleep, is a movement upon the surface of space-time. Your body, your eyes, your heart are all quietly following their own small geodesics. You may be wondering, what about people floating in space? Why do they hover weightlessly? Let us imagine gently, as if drifting in a sleepy current. On the International Space Station, astronauts are not in a place without gravity. Earth's gravity is still there, strong enough to hold the station in its orbit. But nothing is resisting their fall. The astronauts and the station are falling around Earth together, traveling along a perfect geodesic. That is why they float, not because gravity has vanished, but because they are falling endlessly, falling without ever touching the ground. Free fall, in Einstein's language, is the most natural state of motion. No resistance, no holding back, just allowing the body to follow the shape of space-time. Like a leaf drifting with the swirl of the wind, instead of following a rigid, straight line. A falling elevator, a stone slipping from your hand, a droplet forming and falling from the edge of a leaf. They are all moving along tiny geodesics in the curved fabric. And if you could shrink yourself down to the size of a dust grain, you would see yourself sliding gently along those curves, moving as quietly as morning mist on grass. These curves hold planets in orbit, and they bend light as well. When light, the fastest traveler in the universe, must yield to curved space-time, then you begin to see how beautiful this picture truly is. It is not a mechanical model. It is poetry. It is the universe's own artwork. Geodesics are the soft lines the universe writes upon itself. Planets are commas. Light is a period. And you, listening now, are part of that same sentence. And as we gently close the chapter of these invisible pathways, leaving behind the image of a marble rolling across the curved fabric of the universe, something quiet, yet profoundly important, begins to stir in the mind. If space-time truly is a soft fabric, and if everything is following its own geodesic, then does time still behave as neatly and obediently as we once believed? Or does it also bend, stretch, and breathe the way the fabric does? That question rises softly, like a pale streak of moonlight on water, and to answer it, we do not need to travel far. We only need to imagine two small clocks, resting in the deep stillness of night. One sits at the foot of a mountain, where Earth is closer, where gravity is slightly stronger. One sits at the mountain's peak, where the sky opens wider and space is less curved. Though they appear to tick in perfect unison, the two clocks slowly drift apart. In the place where gravity is stronger, time moves more slowly. The difference is tiny, invisible to the eye. If you lived your whole life at the foot of the mountain, you would be only half a trillionth of a second younger than someone who lived at the peak. But in the language of the universe, the difference is real, soft, subtle, but undeniable. Time is not a straight river. Scientists, with the patience of gardeners, began planting their experiments into the sky. They carried clocks on airplanes and flew them around Earth. This time, not only altitude changed time, but speed as well. The faster clocks drifted away from those on the ground. The gap, though small, was clear, like a reminder that every journey leaves a mark on space-time. And perhaps the most magical part lies right in your pocket. Your phone, the one you use for maps every day, depends on clocks that are drifting out of sync. GPS does not simply track the satellite's positions. It must constantly adjust for the fact that the clocks on satellites run faster than those on Earth. In orbit, gravity is weaker and time runs just a little faster. Without those corrections, your map would be off by kilometers within minutes, which means every time you find your way home, you are relying on a quiet conversation between clocks that never fully agree. A conversation shaped by curved time. And now is the moment to pause and breathe softly, because the meaning of this is not only scientific, it carries a gentle philosophy for nights when you feel you are moving too fast or too slow compared to the world around you. Time, which we believed to be fixed, strict, absolute, also changes. It shrinks when gravity is strong. It stretches when space widens. It pulls when you move quickly. And all of this happens silently, unseen, as though the universe is composing its own music for every place and every moment. There is no pair of locations in the universe where time flows exactly the same. There are no two clocks that truly agree, and none of us is living at the same pace as anyone else. Each of us drifts through a timeline tailored just for us. When you stand beside someone you love, when you gaze at the sky, when you lie down and feel your body sink into the bed, the time around you holds a slightly different shape. The universe bends softly, curves gently, and weaves each moment with a melody no one hears, but everyone lives within. Einstein once said that space and time are a single fabric, but we forget. This fabric is so soft that every step, every breath, every mountain, every drop of water leaves a small fold. And in those folds, time changes. The way water changes color under moonlight. We do not need distant galaxies to see this. It is happening right where you sit, in the moment you are listening to this story. And once you realize it, the next question appears naturally. Because if light follows curved pathways, and if time stretches and bends, then what happens when space-time curves so steeply that light cannot escape? When every path slopes downward with no way back? That is where light loses its way, where space becomes a well, where the universe keeps its secrets by closing every door. And as we listen to the whisper of time, a whisper that has already shown us it never flows evenly, another question rises, gently, like a thin cloud crossing the night sky. If time can bend, then might light, the messenger of the universe, ever lose its way? The question comes naturally, as though it had always been waiting at the next turn. Imagine slowly, very slowly, a single ray of light leaving a distant star millions of light years away. It begins a journey longer than human history, passing through clouds of gas, through regions so cold that sound itself disappears, until it reaches a place where space begins to dip. Not because something blocks it, not because someone touches it, but because a massive cluster of galaxies has bent space-time downward like a giant bowl. The ray of light, which always travels straight in its own world, suddenly curves along the rim of this dip, like a grain of sand caught in the swirling edge of a retreating wave. It does not resist. It does not slow. It does not change its nature. It simply follows the path space-time has drawn for it long before it was born. And we call this soft yet majestic phenomenon gravitational lensing. A gravitational lens is not a real lens. It has no edges, no surface, nothing you can touch. It is simply the way space-time curves so deeply that light must turn. But because of this bending, the universe creates strange and beautiful images. galaxies stretched into delicate arcs like glowing brushstrokes in the night. Sometimes the light splits into 2, 3, or 4 images of the same galaxy, shimmering like droplets reflected in a mirror, scattering into many points. These luminous rings, called Einstein rings, are so beautiful they feel like the universe's handwritten signature, a gentle reminder that light is also a traveler, and every traveler can lose their way on a curved road. There is a historical moment that we often retell with a kind, almost affectionate tone. It was the day the sun covered the sky in a total solar eclipse. The scientists waiting for that moment were not there merely to admire the beauty of the darkness, but to photograph the stars that would appear near the edge of the sun. They knew that the light from those stars, passing through the region of spacetime curved by the sun's mass, would shift ever so slightly, subtle as a breath. And when the photographic plates were finally developed, they saw what Einstein had once predicted. Light had truly been bent. The positions of the stars, which had seemed fixed and unchanging, were displaced. That single moment made the whole world tremble, not from noise or excitement, but from a silence inside human understanding. Light, the fastest and most powerful messenger in the universe, had bowed its path to follow the curve of space-time. People often say that was the moment humanity saw general relativity with its own eyes. But for those who love the gentle beauty of the cosmos, that moment felt like a soft reminder. Even light, which seems incapable of straying, has its moments of wandering. And perhaps it is precisely thanks to those wanderings that we see the universe more clearly and even more beautifully. And as we listen to the story of light being stretched, twisted, spun into duplicate images like droplets of water blossoming into many streaks of brightness across a mirror, we begin to realize something very deep. Nothing in the universe is truly fixed. No path is perfectly straight. No ray of light keeps its original form once it has passed through the curved regions of space-time. The universe is not just a place filled with massive objects. It is a soft fabric where every event, from the smallest to the largest, leaves its own gentle fold. Once we understand this, the next step appears on its own, as naturally as breathing. If light can lose its way in this curved fabric, what happens when the fabric itself is stretched, torn into waves, and made to tremble like the surface of a lake in the wind? That is the story of gravitational waves, the ripples in space-time that the universe sends out like distant whispers. So then, if light can be bent, is there any place in existence from which it can never return? The question is soft as a breeze touching your eyelids, yet deep as the silence between two breaths. As your mind begins to sink, we slowly slide into a region of the universe where all familiar rules fade, blur, and dissolve like mist. A realm so dark that it does not merely lack light, it devours the very idea of light. Close your eyes and try to imagine a patch of sky blacker than any night you have ever seen. Blacker than a power outage, blacker than a moonless evening, blacker than the void between the farthest stars. But this darkness is not because nothing exists there. It is because every ray of light that enters can never return. They fall inward, gentle as raindrops falling into a deep well, and then they vanish. This is a black hole, not a place that is black, but a place that is simply impossible to see. Not because it hides itself, but because light itself cannot escape its embrace. People once imagined a black hole as an object, a dark sphere. But it is easier to picture if you imagine the fabric of space-time, the very sheet Einstein wove into human imagination, being stretched so far that it becomes a bottomless pit. A depression that does not merely dip down, but seems to extend endlessly, as if into another realm. Around that region lies a very thin boundary, as beautiful and terrifying as a single taut thread stretched between two cliffs. We call it the event horizon. Once anything crosses that delicate line, it can never turn back. It cannot slow down. It cannot send a signal. It cannot say goodbye. It simply falls inward, not with the jolt of falling from a chair, but like sliding forever down an invisible slope, so smooth and so gentle that you hardly feel you are moving, yet you cannot stop. Deep within, in the region where mathematics, the strongest language humanity has, suddenly falls silent, we give it a special name, the singularity. A place where physical quantities lose their meaning, a place where equations surrender, a place where no one truly knows what happens, and perhaps never will. Then come the stories that sound both chilling and strangely soft, like the footsteps of science fiction. One of them is spaghettification, a word that sounds like the name of a dish, but describes something very strange. If you were to wander too close to a black hole, the part of your body nearer the center would feel a stronger pull than the part farther away. You would be stretched out, longer and thinner, like a strand of spaghetti. Not with pain and panic, but with an absolute stretching of the space-time around you. We do not tell this to frighten you, but to remind you that even at the darkest edges of the universe, there are phenomena so strange that they become beautiful in their own way. A beauty that does not obey human logic. But black holes do not only swallow, they also whisper. Stephen Hawking once showed that the boundary of a black hole is not silent at all. At the event horizon, tiny quantum fluctuations appear and disappear, like flickering lanterns along the edge of an abyss. And sometimes, energy from those fluctuations escapes outward, very slowly, very faintly, like the final breath of a star that died long ago. This phenomenon is called Hawking radiation. Because of it, we know that black holes are not eternal. They can evaporate over timescales longer than the current age of the universe. And so even what seems to be the mightiest thing in existence will one day fade away, not with an explosion, but with quietness. Not in a burst of light, but in the gradual dimming of darkness. When we look into a black hole, in a strange way, we are not only looking into absolute night. We are staring at the edge of human understanding. We are gazing into the region where science itself has to whisper, "I will come back later. I do not understand this yet." After stepping through that absolute darkness, where light surrenders and time seems torn into layers, we leave the shadow of the black hole with a strange feeling. It seems the universe is not as silent as we once believed. If there are places where light disappears, there must also be places where space-time itself quietly breathes and quivers, like the surface of a lake after a gentle wind. And from that deep night, it is as if we have crossed into another room of the universe, where silence is no longer emptiness, but a very faint music you can only hear when you are still enough. Let your breath slow just a little, and imagine that all of space-time around us, the invisible thing we carelessly call air, emptiness, or sometimes nothingness, is actually like a soft lake. Every star, every planet, every black hole rests upon its surface. And when something powerful enough happens, the surface ripples. Now imagine, very slowly, two extraordinary stars. They are small in size but absurdly heavy, so dense that a single teaspoon of their matter would weigh more than Mount Everest. These are neutron stars, or in some cases, two black holes, circling one another. They spin like two dancers who have shared billions of turns, tired yet bound together by an invisible music, revolving and revolving. With each turn they draw a little closer, as though gravity were pulling two cosmic souls into a final embrace. And with every orbit, imagine space-time being pressed and then released, sending out faint ripples that travel across the universe. Like the gentle rings spreading outward when you drop a tiny stone into a perfectly still lake. Those ripples are gravitational waves. They are not light, and they are not sound. They are the vibrations of the universe's very structure, so delicate that they pass through everything, through planets, through your body, through your beating heart, without you ever knowing. To hear such nearly impossible whispers, humans had to build a machine of astonishing delicacy, LIGO. Imagine LIGO as a giant pair of ears in the dark, listening not with eardrums, but with laser beams, so precise they can detect changes smaller than the size of an atomic nucleus in the length of its arms. If the universe has a breath, LIGO is the first ear we built that is sensitive enough to hear it. The first story these ears heard, like the opening note of the universe's grand symphony, arrived in 2015. It was a brief sound, lasting less than a second. A tiny chirp, a short blip, that was all. But in that fleeting moment, two black holes more than 1 billion light-years away merged into one. A portion of their mass, greater than that of the moon, was transformed into energy in the form of gravitational waves. In that instant, the universe roared louder than all the light from all the stars in all the galaxies combined. And yet the human ear heard nothing. Only space-time itself, and the instrument we built, understood that note. When the scientists detected that signal, they did not leap and shout like in the movies. No one screamed. Instead, many fell silent, some with tears in their eyes, because they knew that from that moment on, humanity was no longer viewing the universe with just one sense. We, tiny creatures living on a dust mote drifting in space, suddenly could hear the heartbeat of the cosmos. Think about that over one slow breath. For thousands of years, we have watched the sky with light. But light does not tell the whole story. It is like seeing someone speak and never hearing their voice. Now, thanks to gravitational waves, we can listen to what light will never reveal. We can hear black holes swirling together. We can hear neutron stars collide. We can hear the universe moving in absolute darkness. And strangely, all of it sounds very quiet. Not like an explosion, not like a roar, but like a tiny, soft vibration, the way a newborn's heartbeat might sound to a mother holding them close in the dark. From this point on, you may find yourself looking at the night sky differently. Those tiny points of light are not only shining, they are also gently stirring the surface of space-time all around you. And you, even as you lie still in your small room, are resting right in the middle of that great symphony. The universe is not silent. It simply whispers in a language we have only just learned to hear. And as the echo of those gravitational waves fades away in your imagination, like the final notes of a distant orchestra dissolving into the dark, you suddenly realize something very simple, yet overwhelming. For those faint vibrations to reach the place where you are lying now, they had to cross countless nameless shadows, regions where light has never set foot, parts of the universe that remain still and wordless, as if not yet ready to tell their story. From that endless silence, we step into the next chapter, one that modern science, despite all its efforts, has only brushed with its fingertips. Let your body soften a little more. Let your breath fall lightly like cosmic dust, and look with me at that vast sky. When you tilt your head toward the night, those tiny points of light, the stars, the galaxies, the thin white river of the Milky Way, are really just the surface of a bottomless ocean of darkness. The strangest part is not what we see, but what we do not see, because most of the universe is, in truth, hidden away. It sounds like something out of a fairy tale, but science has been quietly whispering this for decades. The brightest things make up only a very small part of the true picture. All the glittering stars, the colorful nebulae, the spiraling galaxies that turn like flowers of light. Together, they account for only about 5% of the universe. The rest is darkness. Not darkness in the sense of gloom or fear, but a silent, invisible fabric, heavy with mysteries that human intellect has not yet reached. Jen, imagine an invisible hand resting on each galaxy. No one can see this hand, no one can touch it, but you know it is there because it keeps the stars at the galaxy's edges from being flung into the void. They spin so fast that, based only on the visible mass, They should long ago have flown away, and yet they remain, circling calmly and steadily, as though a gentle but unyielding force were holding them from behind. That force comes from dark matter, which does not shine, does not reflect light, does not absorb light. It is completely invisible, yet it makes up about 27% of the entire universe. It is like the skeleton of the cosmos, the structure that holds everything in place, that lets galaxies stay together, that keeps colossal structures from collapsing. If dark matter is the hand that holds things in, then dark energy is like a great wide breath, pushing everything apart. It makes up about 68% of the universe, a number that feels almost absurd to human intuition. Dark energy does not merely make the universe expand, it makes the universe expand faster and faster with time, as though space-time itself wants to stretch, to lengthen every gap, softly and continuously, like someone opening a vast door that never stops moving. It is dark energy that led scientists to a quiet but astonishing conclusion. The universe is not just growing. It may one day thin out into an endless emptiness, where galaxies drift so far apart that their light will never meet again. If we trace time backward, far beyond all the stardust, beyond every gravitational ripple, beyond even the dark regions where light has never been named, we return to the first moment, the Big Bang, a point unimaginably small, unimaginably hot, unimaginably dense, where the entire universe was contained in a single first heartbeat of space-time. From that instant, the universe began to unfold like a flower opening its petals. First quickly, then more slowly, then faster again. And it was gravity, together with those two quiet dark actors, that decided the rhythm of that opening, how far it would spread, and whether its future would be a blaze of light or an eternal deep night. As you lie here in your room, listening to these stories drift by like gentle waves, remember that your body, every atom, every molecule, is also the result of that expansion. You are part of this endless unfolding, part of the mysteries that even modern science still finds bewildering. The universe is so vast it can make a human feel tiny. And yet it is gentle enough to give each of us a place, a reason, a journey. And in the great darkness that makes up almost everything, you still shine, even if only like a tiny point. But you are the only kind of light that can think, feel, and smile while listening to the tale of the very universe that made you. Now, as we step out of the story of the universe's dark side, a part so immense it lies beyond all language and imagination, you might feel a rare stillness inside. Not the emptiness of a void, but the stillness you feel standing before a boundless ocean at night, knowing that what lies ahead is infinite, and yet somehow, you feel more at peace than ever. It is in that moment that tonight's journey brings us back to where it began, with you, lying quietly in your small room, breathing softly in a universe that is still expanding. Let your body sink deeper into the mattress, as if Earth herself were gently holding you. Your eyelids may already feel heavy, your eyes closing more willingly now, as if they too are tired after traveling through all those layers of space-time. Your breath has slowed, grown steady, like the quiet heartbeat of the cosmos. Not rushed, not hurried, just flowing quietly with the motion of all that exists. And now, in this in-between state where you are half awake and half dreaming, let me whisper this. Gravity, the thing you always thought was a rope pulling you down, is not actually some force grabbing at you. It is simply the way the fabric of space-time beneath your back curves ever so slightly because of Earth. That gentle curvature, so soft and so natural, is what makes your body want to stay where it is, want to rest right here. So every step you take during the day is not just a step on the ground. You are traveling across the surface of a vast cosmic fabric. where each step is a tiny curve in space-time. Every fall, every jump, every embrace unfolds atop a universal stage you can never see, but which is always there. And realizing this can feel like discovering a quiet, beautiful secret of your own. When you see the world this way, the universe stops feeling like a box full of separate objects and becomes a living web of connections between matter, energy, space, and time. Everything is related not by visible threads, but by subtle curves, soft and ever-present. And then, the big questions that once made us anxious. What is outside the universe? What was before the Big Bang? Suddenly feel lighter. Because perhaps those questions are using the wrong language. When space-time itself is the whole frame of reality, asking, what is outside the frame, is a bit like asking, what is outside the dream? While you are still dreaming. And maybe the most beautiful thing is not the answer, but the fact that humans keep asking, keep searching, keep listening for the faintest tremors of the universe. Even though science has helped us understand so much, there are still gaps unfilled. The conversation Einstein began with time is not yet complete. The puzzles posed by quantum theory still do not quite fit the larger picture. Dark matter and dark energy, the two ingredients that make up 95% of the universe, still stand there in silence, like pages of a book never opened. And that means this: your generation, mine, all of us lying here in the dark listening to this, have only walked along the first stretch of the path. Future generations will continue writing the universe's story, a story to which we have turned just one more page tonight. Now, before your last thoughts dissolve softly into sleep, let me offer you a tiny meditation, light as a shawl laid gently over your shoulders. You, with every atom in your body, are the result of billions of years of the universe bending, expanding, exploding, cooling, and exploding again. Those atoms were once light, once stardust, once the breath of giant stars that died so that life could exist. There is no planet, no human, no night of sleep that has not passed through those cycles. So when you close your eyes, you are not separating yourself from the universe. You are returning to it. You are lying upon the very fabric of space-time that has held everything since the beginning. And you are breathing with it. A slow, deep, gentle breath, as if the universe itself were settling down beside you. So tonight, allow yourself to float a little. Let your thoughts fall away, light as star ash. Let sleep come to you like an ancient whisper, traveling across billions of light years, and then softly laying a hand over your heart to say, you belong to this universe, and in its own quiet way, the universe belongs to you too. Sleep well.
you